Organisms, whether they're producers or consumers, are composed of cells. The cell is the basic structural unit of living things.
So if all organisms are made of cells, then this horse and these oats must be similar.
Well, they don't look very similar.
Actually, there are a lot of similarities and very few differences. It just depends on how closely you look at the two organisms. For instance, all cells must divide to form new cells. What else would be similar?
All cells must need food.
And why?
To get energy for life functions and the matter they need to grow.
Right. Cells must have a system for converting available energy into a form they can use.
So that's why plants use photosynthesis.
Well, cells also have to get rid of their wastes.
Are producers' cells different than consumers?
Well, yeah.
Can you see the difference?
Well, you can if you have the right equipment.
So then we must need a microscope.
Well, it's a compound light microscope, to be exact.
The compound light microscope has changed our understanding of life. Before its invention, scientists saw living systems as whole units. They didn't realize these units were made up of cells. Let's take a look at this groundbreaking microscope. The eyepiece, or ocular lens, magnifies the image that the objective lens produces. There are three objective lenses: low, medium, and high power. They project a magnified image of the viewed object. A microscope's total magnification is the product of the magnification of the objective lens and the ocular lens. The stage is where you put the slide to be viewed. Stage clips hold the slide in place on the stage. The iris diaphragm controls the amount of light which enters the specimen. The condenser lens focuses the light before it passes through the specimen. There are two focus knobs. One is the coarse adjustment, which focuses the image. The other is the fine adjustment, which sharpens the image, enabling you to see the various levels of the specimen.
Along with chemical analysis, how do you use microscopes in your work?
Microscopes give us a really fascinating picture of the internal structure of the human skeleton. We can take a bone like this thigh bone, we see the gross morphology, we can take a longitudinal section to look at the internal components of the bone, but we can also take a very small piece from a cortical cross-section, the compact bone that makes up the outside of that. We grind it so that it's very thin, put it on a glass slide like this, and look at it under the microscope. And what we've got here, this monitor is showing the image that you're getting through the microscope lens, and this will show us all of the internal structures that are in your long bones. Places where the blood vessels and nerves run, how the bone has been formed, and the spaces where the bone cells lived when the bone was alive.
A microscope is an expensive piece of equipment, so it's important to learn how to use one properly. With a good compound light model, an image can be magnified over 1,000 times.
Focusing a compound light microscope is pretty easy. You just follow a few simple steps. Place a slide on the stage. Start with the low-power objective lens and the stage in the position closest to the lens. Using the coarse adjustment, focus by moving the stage away from the objective lens.
So when do you use the fine adjustment?
Only with medium or high objective lenses. When you change to medium or high power, watch from the side to make sure that the lens doesn't touch the slide.
So I guess you could say learning to use a microscope is the first step to seeing life more clearly.
You could say that. Living organisms are made of cells, so being able to see cells more closely makes it easier to understand how life works.